Okay guys, we are going to finally do our stoichiometry lesson. So before we get into stoichiometry, let's do problem solving review. Okay? So we did this in the mole unit. We also did this in the beginning of the year with conversions. So let's review. So the purpose of using the fence post method, or T-chart, whatever you want to call it, is converting between units. So that's what we're going to be doing. The first step in a fence post problem is to put the given information on the line. From this point forward, if you haven't been doing this, you want to definitely include the units and the substance. And just a reminder, so a conversion factor is equal to 1. So like 12 feet is, or excuse me, 12 inches is 1 foot. That's equal to 1. The top number is equal to the bottom number. So how do we determine where to put what part of the conversion factor and why? And so remember, the rule is the diagonal units always have to match. And the reason why is so that they cancel out. So which conversion factor do we use? You read the problem and see what they give you. And that's going to tell you where to start. So if they give you mass in the problem, you're going to have to use molar mass. If they give you atoms in the problem, you're going to have to use Avogadro's number. So then how do you determine if you need more than one? Well, if you use the first one and what you're looking for isn't on the top when you're done, then you need another one. Okay? So then the question is, how do I know when I'm finished? Well, when you're finished, you're going to end up with what you're looking for. So all the stuff will cross out except for what you're looking for. So we're going to do these practice problems, and when we do them, you want to be flipping to your flowchart. Okay, that's going to tell you what to do. So number 9 says, sulfuric acid is formed when sulfur dioxide reacts with oxygen and water. Write a balanced chemical equation for the reaction. And then it goes on to ask you how to do the problem. So in this chapter, we have to remember everything that we learned last chapter. For this chapter, you're going to have to be able to do equations again. And if you can't, I will offer you 2 versions of the test again. I will offer you a version where you don't need to know how to write an equation and one where you do. Okay, but the one that you don't have to, it is only going to be worth 80 points, and the one that you do have to will be worth 110 points. Just like we did last chapter. Okay, so we're going to write this. Sulfuric acid is formed, so that's going to be on the right side of the equation. I know an acid always starts with H. I know sulfuric acid is formed with sulfate. And so if you don't know that, look that up on the back of your periodic table. But hydrogen charge is 1, so it's going to be H2SO4. And I know that for 2 reasons. 1, it doesn't have a hydro, and 2, it has this ick on it. If it had an us, then it would be sulfurous acid, and that would be sulfite. Okay. So we know that's formed when sulfur dioxide, now sulfur is S, oxide is oxygen, and di is 2. So sulfur dioxide is written like that, with oxygen and water. With oxygen and water. Now oxygen is always going to be O2 because it's diatomic, and you know how to write water. Okay, so it says if we have 12.5 moles of sulfur dioxide, how many moles of sulfuric acid can be produced? So that's question 1, and then question 2 is how many moles of O2 is needed? So before we move on, we need to balance our equation. Our S's are balanced, our O's are not balanced, and our H's are balanced. So let's see if we can do something with these O's. I'm going to put a 2 in front of here because that will give me an even number of O's on the left side. And that means I have to put a 2 over here to balance my H's now. So on this side currently I have 8 O's, and on this side I have 6. So I'll put a 2 in front of here, and then that should balance it. Okay, so on to our problem. We have 12.5 moles of SO2. They want to know how many moles of sulfuric acid can be formed. So, if you're using your flowchart, they give us moles of substance 1, they want moles of substance 2. So the only thing I have to do is use a mole ratio to do that. What is a mole ratio? Remember that a mole ratio is the coefficients. So these two coefficients is our mole ratio. And remember, this is empty, so it's a 1. So for every 1 mole of sulfur dioxide I have, I can make 2 moles of sulfuric acid. So 1 mole of SO2 is equal to 2 moles of sulfuric acid. And then that's the only step that I have to do because I'm given moles of substance 1 and I want moles of substance 2. So it's 12.5 times 2, which is 25. For sig figs, I'm going to put 25.0. And that's my answer. So for the second part, they're asking how many moles of O2 is needed. So you're going to always start out the same way. You're going to start with what they give you. And notice we're going from moles of substance 1 again to moles of substance 2. So we're doing the exact same thing. We're going to do the mole ratio. And the mole ratio in this case is 1 mole of sulfur dioxide to 2 moles of oxygen. And that's the only step. So again, our answer is 25.0 moles of oxygen. Let's do number 10. So you guys, this would be the difference between the easy test and the hard test. Number 9 would be an example of the hard test. I had to write the equation by myself. That test is going to be worth 110 points. Number 10 is an example of the easy test. The easy test will only be worth 80 points. So the best you can do is an 80%. And they give you this equation. Okay. You still have to balance it though. So my C's are balanced, my H's are not balanced, so I'm going to put a 2 there. And that balances my H's. But my S's are not balanced. I have 2 here plus 2 here. That's 4, and there's 8 here. I need a total of 8 on this side somehow. But if I change this number, I'm going to mess up my H's, and if I change this number, I'm going to mess with my C's. So what I'm going to do is I'm going to try to double this and see what happens. If I double this, that's 2 carbons, which I need to put a 2 here, and that's 8 H's, so I need to put a 4 here. So let's see what that does. So now my C's are balanced. My H's are balanced, and my S's on this side, I have 2 times 2, which is 4, and then I have 4 times 1, which is 4, and 4 plus 4 is 8. So that actually balanced it. It was basically trial and error on my part to see what worked. Okay, so we did A, balance the equation. Now we need to calculate the moles of CS2. So how many moles there? When we start with 1.5 moles of S8. So, we're going to start like we always do. We write down what they give us. And then they give us moles of substance 1 and ask us to find moles of substance 2. So again, we're using that mole ratio. So the mole ratio for this guy, this is a 1 and this is a 2. So for 1 mole of S8, we have 2 moles of CS2. And then that would be it. So we're going to have 3, and I'm going to do 3.00 here for sig figs, moles of CS2. Now we do have another problem here. They ask us how many moles of hydrosulfuric acid could be produced. So they're asking you how many moles of this. And you guys always want to start with the thing that they give you, if you can. And so we're going to start with the moles of S8. And realize we're still doing this moles of substance 1 to moles of substance 2 thing, so we're still going to use the mole ratio. So the mole ratio is different this time because for every 1 mole of S8, you make 4 moles of hydrosulfuric acid. So for 1 mole of S8, we have 4 moles of H2S, and then that's our answer. So 4 times 1.5 is 6, and I'm going to do 6.00 for sig figs. So these are the easy problems. These are all one-steppers. On the back, they get to be a little harder, but still easy. So I'm going to do one more with you, and then I'll let you do the last 3 on your own, and then in the next video, I'll show you how to do the really hard ones. So let's do number 11. Now number 11, they give me the equation. So this is a kind of question that would be on your easy test, okay, your 80-pointer. So you have to be able to do that on your own. Okay, so if I begin with 1.25 moles of titanium oxide, so 1.25 moles of this, they're asking for the mass of chlorine that you need to react with that. Mass is grams. So let's look at our flowchart and see what's different here. So they give us moles this time, so we're starting in the same spot. The difference is I have to use my mole ratio to get the moles of substance 2, and then I need to convert that to mass. So I'm going to do 2 steps. I'm going to do 1 step with the mole ratio like we've been doing, and then I'm going to do another step using the molar mass to get to grams. So let's see how this works. So we have 1.25 moles of titanium oxide, and the mole ratio is here. For every 1 mole of titanium oxide, I have 2 moles of chlorine. And so before we were stopping at this point, in this particular case, we don't want moles of chlorine, we want mass of chlorine. So this is where your periodic table comes in. So we've done this step, we're going to do this step, and this step says get the molar mass from the periodic table. So you're going to look up Cl on the periodic table, and you're going to multiply by 2 because it's Cl2. We're going to do 35.453 times 2, and that's our answer, 70.906. Now, here's the important part. Where do you put what? So we know that molar mass is the mass of 1 mole. So the 1 mole is going to go down here. And look why I do that. I need moles down here so the moles cancel out. And then 70.906 grams of chlorine. So remember how to do our math in these problems. We're going to take the 1.25, we're multiplying it by 2. We're also multiplying it by 70.906. And then we're dividing it by 1, dividing it by 1. And you guys are smart, you know that I don't actually have to do the division because it will be the same thing. So the answer is 177, and I'm doing 3 sig figs here because they gave me 3 sig figs, grams of chlorine. Okay, so the next 3 should be in the realm of that difficulty, and then see the next video for the next page.